Good morning class. Today we discuss primary cell, secondary cell, fuel cell. Now let us discuss primary cell. Primary cells are those cells in which the redox reaction take place only once and they become dead after some time. For example, dry cell, mercury cell or button cell, etc. I repeat again, primary cells are those cells in which redox reaction take place only once and they become dead after some time. Example, dry cell, you can say pencil cell, comma mercury cell or button cell, etc. In primary cell, zinc container is there which act as anode, that is the negative terminal, in which graphite fluid is there which act as cathode. Here manganese oxide and carbon mixture is filled in a porous paper container which in which outside there is ammonium chloride and zinc chloride paste. The use of zinc chloride here is to prevent the formation of ammonia. Otherwise, the pressure of ammonia will burst the cell. Now, let us consider the chemical reaction take place in dry cell. Before we discuss, first we must know that how much voltage we obtain from dry cell. It is 1.25 to 1.50 volt voltage take place obtained from dry cell. In dry cell, at anode, zinc on losing 2 electron converted into Zn double positive ions. At cathode we have graphite. Now at cathode, student, we have manganese dioxide which combine with ammonium ion that produce MnOOH along with ammonia gas. The role of zinc chloride filled in dry cell is to form complex with combination with ammonia. Otherwise, ammonia produced inside the cell would break the seal of cell. So these are the reactions that take place at cathode and anode in dry cell. Now let us discuss mercury cell. Mercury cell. It is said to be button cell or Rubin-Mallory cell. It should be noted mercury cell gave constant voltage throughout its life because the overall reaction do not contain any ion whose concentration affected. Here is a systematic diagram of mercury cell in which carbon cathode is there and the zinc container anode is there. In mercury cell there will be the paste of mercury oxide along with KOH. Now let us, it gives the constant voltage about 3.5 volt throughout its life because the overall reaction do not contain any ion. Now let us discuss the reaction take place at cathode and anode in mercury cell. At anode, zinc ion combined with 2 OH negative ions to give zinc oxide along with H2O plus 2 electrons. At cathode we have HgO, mercury oxide, which combine with water along with 2 electrons to form. At cathode we have mercury oxide which combined with water and 2 electron gives mercury along with 2 OH negative ion. For overall reaction we should add reaction at anode and cathode, we get overall reaction. Here one question may be asked in board examination: why the mercury cell give constant voltage throughout its life? Because the overall reaction do not contain any ion whose concentration affected. One more question may be asked from this topic: why the dry cell become dead after some time even when not in use? Since the acidic ammonium chloride present in dry cell corrode the zinc container, therefore they become vanish after some time. Now let us consider secondary cell. Those cells which can be recharged again and again are said to be secondary cell. I repeat again, those cells which can be recharged again and again are said to be secondary cell. The best example of secondary cell is lead storage battery and also lithium ion battery used in mobile phones. Now let us consider lead storage battery. Student, in lead storage battery 38% solution of H2SO4 used as electrolyte. 38% solution of H2SO4 used as electrolyte. Now let us consider the reaction take place at anode and cathode of lead storage battery. It is an example of secondary cell. Now let us discuss the reaction take place at anode and cathode. At anode, lead combine with sulfate ions to form lead sulfate along with 2 electrons. I repeat again, at anode, lead combine with sulfate ions to form lead sulfate along with 2 electrons. At cathode, lead oxide combined with H positive ion along with sulfate ion along with 2 electron give again lead sulfate precipitate along with 2H2SO4. I repeat it again. At cathode, lead oxide combines with H positive ion along with sulfate. 2 electron give lead sulfate along with water. In overall reaction we are adding these equations. We get lead plus lead oxide. Here the 4H positive is there and 2 sulfate is there, so you can write it 2H2SO4 gives 2PbSO4. It is obtained as white ash on the terminal of battery. P2PbSO4 plus 2H2O. So it is the reaction that takes place in lead storage battery. At anode, lead combined with sulfate ion to form white ash of lead sulfate along with 2 electrons. At cathode, lead oxide combined with hydrogen ions along with sulfate ion with 2 electrons gives lead sulfate with water. In overall reaction, we are adding these. Now let us consider fuel cell. To students, fuel cell is a device which generates electricity by the combustion of fuel like hydrogen, methanol, methane directly. For example, H2O2 fuel cell. It is used in Apollo spaceship. Now let us discuss the reaction take place at cathode and anode in fuel cell. Before discussing reaction, first we draw the diagram, systematic diagram of fuel cell. In fuel cell, this type of figure is there in which aqueous electrolyte is filled. In which aqueous electrolyte will be filled. Here at the left hand terminal, here the hydrogen is introduced. On right hand side, oxygen is introduced. The byproduct of fuel cell is water. Here the left hand terminal of this fuel cell is negative and right hand is positive. It is called anode and this be called cathode. It should be noted fuel cell has advantage. It has a high thermodynamic efficiency, about 70%. Means suppose 100 kilogram fuel is there, so we will obtain energy out of 100, 70 kilogram fuel is converted into useful energy. Second is it can be operated at temperature range from 70 degrees centigrade to 140 degrees centigrade. Third one is it does not create any pollution. Now let us discuss the chemical reaction take place inside the fuel cell at anode and cathode. At anode, hydrogen is there. At anode, hydrogen is there, which combines with OH negative ions. Which combine with OH negative ions to form water along with 4 electrons. I repeat it again. At anode, hydrogen is there, which combine with OH negative ion to form water along with 4 electrons. At cathode, oxygen combine with water along with 4 electrons. We will, I repeat, at cathode, oxygen combined with water along with 4 electron gives 4 OH negative ion. For overall reaction, we are adding these two equations. We get 2 hydrogen gas when combined with oxygen gas produce 2 H2O liquid. That is the overall reaction take place in fuel cell. I repeat again. Fuel cell is a device which generates electricity by combustion of fuel directly. It is a systematic figure for fuel cell. Fuel cell has high thermodynamic efficiency. Fuel cell can be operated from temperature range from 20 to 140 degrees centigrade. It does not create any pollution. The chemical reaction take place in fuel cell as mentioned. Now let us discuss the last topic of this chapter. It is corrosion. The eating up of metal surface by atmospheric gases and moisture is called corrosion. I repeat, the eating up of metal surface by atmospheric gases and moisture is called corrosion. For example, rusting of iron. There are the certain factors which promotes corrosion. These are reactivity of metal, strain in metal, presence of electrolyte, and presence of air and moisture. So these are the some factors which promote corrosion. For example, rusting is rapid in saline water because in saline water concentration of electrolyte is more, which promotes corrosion. Now there are some methods by which we prevent corrosion. Some of them are oiling and painting along with greasing, anodizing, that is the developing of oxide layer on aluminium container, galvanization, that is developing zinc layer on iron container, electroplating, sacrificial protection. In petrol pump, the oil is filled in iron tank, which are further connected with a magnesium rod. Since magnesium is more reactive than iron, corrode first, which prevent iron to corrosion. Now let us discuss the reaction take place during corrosion of iron. During corrosion of iron, at anode, iron is there. I repeat again, during corrosion of iron, at anode, iron is there, which oxidize into Fe2 positive along with 4 electron. In corrosion, at anode, iron is oxidized to Fe double positive along with 4 electron. At cathode, oxygen gas when combined with 4H positive along with electron, we will obtain 2H2O. We will obtain 2H2O. In overall reaction, we are adding these two equations. We get here 2Fe solid when combined with oxygen along with hydrogen gives 2Fe2 positive along with 2H2O. So these are the reaction take place during corrosion of iron. These reactions are associated with corrosion of iron or rusting of iron. You can say rusting of iron. Now the some questions are there. Why rusting is rapid in saline water? Since saline water contain more electrolyte which promote rusting. It should be noted rusting inhibited by the alkaline medium since H positive ion combined with OH negative ion to form water, thus inhibit rusting. Next question is, what is the role of salt bridge in galvanic cell? Student, salt bridge provide path for flowing ion. That's why we put salt bridge in galvanic cell. Thank you very much.